Hello. In this video, I am going to demonstrate how to reduce a matrix that is in augmented form to reduced row echelon form. All right, so let's get started. The first matrix that I'm going to work with is matrix A. Now, matrix A, because it's an augmented matrix, is created from three different equations because we have three different rows and three different variables. Let's just say that this variable right here is x, and then y and z, and these are our constants. What we want to do is reduce that to reduced row echelon form. So let's go to Desmos. The first thing that we do once we've opened up Desmos is click on New Matrix. And over here, it's going to start off with A, and it automatically starts it off as a 2x2 matrix. And we can change that down here. We have rows. We can either reduce the number of rows or we can increase the number of rows. We can reduce the number of columns or we can increase the number of columns just by clicking on the plus or the minus. So for this particular problem, we want 3 rows and 4 columns, which is exactly what we have here now. Now, very carefully, go through and enter in the numbers into the matrix. So in this matrix A, we're going to be starting off with 1, and then 0, -3, -2, 3, and I'm just clicking on the little arrow key. The right arrow key keeps me moving right along through here. Arrow key 2214, 2214. And before I do anything, I like to double check to make sure that I entered everything correctly. So again, we have 1, 0, -3, -2, 3, 1, -2, 5, 2, 2, 1, 4. So we want to reduce this to reduce row echelon form. So what I like to do is just kind of click up here someplace, and then we get this down here. And what we're looking for is RF, which means reduced row echelon form. So click on that, and it gives you RF in parentheses up here. And so what you want to put in the parentheses is A, because we want to reduce matrix A to reduced row echelon form. It will actually do it without putting the closing parentheses, but I just like to throw that in there anyway. And then way over here on the right hand side, we will get the reduced row echelon form. And so I've copied that already over here. So let's just take a look at this to first of all examine that it actually is in reduced row echelon form. So let's take a look at our pivots. So we have a pivot here at 1, we have a pivot here, and we have a pivot here. So this is the X row, the Y row, the Z row, and constants. So this is in, first of all, it is in row echelon form because each row with a pivot is to the right of the pivot in the preceding row. In addition to that, it's in reduced row echelon form because all of the pivots are 1s and every other entry in the pivot column is a 0. So the pivot is a 1 and we have zeros. In the Y column, we have the pivot is a 1 and we have zeros. In the Z column, we have a pivot of 1 and all zeros. To obtain the answer, the solution to this particular matrix, all we have to do is realize that this says 1x is equal to 4. And so we have 1y is equal to -3, and 1z is equal to 2. And that is the solution to the system of equations that we obtained this matrix from. Now, just a little bit more terminology that we've learned in class. We know what these pivots are. Every column that has a pivot is a basic variable. So our basic variables are x, y, and z, because the x column has a pivot, the y column has a pivot, the z column has a pivot. So the basic variables are x, y, and z. So all of the variables are basic variables. There are no free variables. No free variables. Now this tells us something very important. If there are no free variables, then we know that we are going to have a unique solution, which we do. This is a unique solution. X is equal to 4, y is equal to -3, z is 2. One solution, one unique solution, no free variables. All right, let's take a look at matrix B. Matrix B, if this came from a system of linear equations, and this is an augmented matrix, then we have an x column and a y column and a constant column. But we have three equations that these came from. Three equations in two variables. So to get this in reduced row echelon form, let's go back to Desmos. So I am going to click on New Matrix, and it's now going to give me a matrix B. Matrix B should be a 3 by 3 matrix, so I'm going to click on rows +1 and columns +1. And now I'm going to start entering my numbers, which is -3, right arrow, 5, right arrow, -22, right arrow, 3, 4, 4, 4, -8, and 32. And let's just double check the numbers. So -3, 5, -22, 3, 4, 4, 4, -8, 32. There's my matrix. Let's go down and click on, well, we don't have to click on RF because we still have it up here. So all I need to do is take out the A, click on delete, and put in B. And now over here, it gives me my reduced row echelon form. And so I've taken and copied that right here. So let's analyze this. Is this indeed in reduced row echelon form? So let's take a look for our pivots. We have a pivot of 1. We have a pivot of 1. And we have no more pivots. We do have a row of zeros, and the row of zeros is at the bottom. So remember, every row that has a pivot, that pivot has to be to the right of the pivot in the row above it, which this is. If there is a row of zeros, it should be at the bottom, which it is. So this is in row echelon form. Is it then in reduced row echelon form? So to be in reduced row echelon form, we want the pivots to be 1s, which they are. And then every other entry in the pivot column is a 0. So 1, 0, 0, 1, 0, 0. That is in reduced row echelon form. Let's take a look at the basic variables here. The basic variables, so if this is x and this is y, then x and y are both basic variables. And there are no free variables. Since there are no free variables, there will be a unique solution. And we can see that there is a unique solution because we have 1x equals 4, and we have 1y equals -2. And there is our one unique solution. Another term that you're going to be learning in class is the concept of rank. Rank is simply the number of basic variables. So the rank is 2 because we have 2 basic variables. That's really all it is. It's the number of pivots. We have 2 pivots, which is the same as the number of basic variables. If we go back up to the first problem, the rank is 3. Go back up here. The rank of this matrix, the rank of A, is 3. Why? Because we have 3 basic variables, x, y, and z. Alrighty, let's go to matrix C. So if C came from a system of equations, it looks like we would have an x column, a y column, a z column, and then our constants. So this is 2 equations in 3 variables. Let's reduce that to reduced row echelon form. So I'm going to click on New Matrix, and I want a 2 by 4, 2 rows, 4 columns. And my entries are going to be 1, -3, 2, 18, 5, -15, 10, and 18. Let's double check those numbers. They look good. And now let's go up here to RREF and put in C. Then over here on the right, we have our answer. And so I've copied that over here. Now let's just verify that this is in reduced row echelon form. So we have a pivot, and then we have nothing else. So remember, these are this is the X, the Y, the Z, and this is the C column. And everything here is a 0, and we have a 1. So this is problematic. We don't have a row of entirely zeros, and we don't have any other numbers in the X, Y, or Z columns. This one over here doesn't count as a pivot. The number in the C column will not count as a pivot. And so there is no other pivot here, but we have zeros equal 1. So this is like saying 0x plus 0y plus 0z is equal to 1, or 0 equals 1. And we learned in class that this is a contradiction, which means there is no solution. So you can see when you get this into reduced row echelon form, or as close as to reduced row echelon form as we can get it, that when we have a row of all zeros except for the very last column, that means there's going to be no solution, and we don't need to do any more work. We're done. All right, let's go to the last problem, matrix D. So it's a little bit bigger matrix. So in matrix D, we have an X column, a Y column, Z, and let's call that W. And there are my constants. So I have 4 variables, and I have 4 rows, so that means I have 4 equations. 4 equations, 4 variables. And so let's enter that into Desmos. We want a 4 by 5 matrix. And our entries are 1, 1, 1, 1, 6, 0, 1, -2, -3, -12, 0, 7, 4, 5, and 22, and 0, 1, -2, 0, 1, -2, 0, -6. Time to double check. It's very easy to enter something wrong. 1s and a 6. And it looks like it is good. So let's figure out reduced row echelon form. Replace the C with D. And over on the right, we get our answer. And I copied that over here. So first of all, is this reduced row echelon form? Well, we have pivots here, and here, and here, and here. So every pivot in a row is to the right of the row above it. So if this is X, this is Y, Z, W, and C, then we can see several things. X, Y, Z, and W are all basic variables. Basic variables are X, Y, Z, and W. The rank is equal to the number of basic variables, which is 4. There are no free variables. So if there are no free variables, we are guaranteed a unique answer, one unique solution. And so we can see that we have X equals 1, Y equals 0, Z equals 3, and W equals 2. All right, so this is how to use Desmos. It's really pretty simple, and I hope you guys enjoyed this video. I made this video so that I don't have to go over all of this material during the precious little class time that we have. All right, see you in class.